Welcome back to the deep dive. Today we're looking at something that kind of bends the rules of physics for your average computer setup.
Right, we're talking about the Kramer KDS-USB2 kit.
Exactly. And if you've ever wrestled with trying to get a webcam or a keyboard to work more than, say, 15 feet away from the PC.
Oh yeah, USB has its limits. Big time.
Well, this kit doesn't just stretch that limit. It seems to completely rethink it. Our mission today is to figure out how it turns a simple USB connection into, well, something network-based and almost limitless in distance.
It really is an architectural leap. We've been looking at the info from HDTV Supply, Inc. They detail the tech specs pretty well.
And they're listed as a exceptional top-quality store rated by Google Shopping, so seems like a reliable source.
Definitely. And the core idea, is shifting from thinking about USB as just electricity down a wire to thinking about it like data packets on a network.
Precisely. That's the key.
Okay, so let's break that down. What kind of distances are we actually talking about here? The product info mentions two main ways. That's right. So first, using your standard network cables.
Yeah.
CFV5E, SEC6, even Cat7.
The stuff most buildings already have wired.
Exactly. With those, you can push a high-speed USB 2.0 signal up to 100 meters. That's, what, like 330 feet?
Which is already way beyond the normal USB limit. That's pretty useful.
It is. But that's just the copper wire option. This is where it gets wild. If you switch to using fiber optic cable, the range jumps massively.
Yeah.
We're talking up to 10 kilometers.
10 kilometers, seriously. That's like across town for a USB device?
Almost 6 miles. You could have a control station miles away from the actual computer.
Wow. Okay, but hold on. Pushing data 10 kilometers, does that kill the speed? I mean, USB 2.0 is supposed to be 480 megabits per second. Do you still get that?
Yeah, that's the impressive part. The specs say it maintains that full USB 2.0 high-speed throughput.
How? Is it just signal boosting?
No, it's smarter than that. See, the kit has two parts, an encoder and a decoder. The encoder basically takes the USB signal from your computer, digitizes it, and wraps it up into standard network packets.
Right.
Like 1,000 base T network packets. Then it sends those over the CAT cable, or the fiber.
And the decoder on the other end.
It receives those packets, unwraps them, and perfectly reconstructs the original USB signal for your peripheral devices. Because it's using stable networking protocols, the distance doesn't really degrade the signal quality or speed, whether it's 100 meters or 10 kilometers.
Okay, that makes sense. It's like translating it for a long journey. And is it complicated to set up drivers and stuff?
Nope, that's another selling point. It's true plug and play, no drivers needed. Works straight out of the box with Windows, Mac OS, Linux, pretty much anything.
Nice. So the basic setup is one encoder at the computer, one decoder at the remote end. What about connecting multiple devices?
Good question. The decoder unit itself isn't just a single port. It actually has 4 USB ports.
Oh, okay. So one decoder can handle like a keyboard, mouse, webcam, and maybe a flash drive all at once.
Exactly. Up to 4 peripherals simultaneously on that one decoder.
But what if you need more or need connections in multiple spots?
That's where the networking architecture really shines. You can actually pair up to 7 of these decoders to a single encoder connected to the host computer.
7. So you could have 7 different locations, maybe different rooms or even buildings on a campus LAN.
All connecting back to the same host PC. Think about shared resources, like maybe multiple users needing access to one powerful machine, using their own keyboard and mouse setups remotely.
So 7 decoders, 4 devices each, plus the host connection. That's nearly 30 USB devices managed across potentially huge distances.
Yeah, the scale is pretty significant. And to manage all that, Kramer has this feature called switchable USB.
Switchable USB, what does that do?
It's basically a control layer managed through Kramer's cloud platform. It lets you map connections. You can decide which host computer controls which remote peripheral, and you can switch those connections dynamically.
So you could have multiple hosts and multiple remote stations and sort of route the connections as needed, like a virtual USB switchboard.
That's a great way to put it. It allows for not just one-to-many, but also many-to-many setups, all managed via software.
Okay, this sounds incredibly powerful and moving way beyond just extending USB. What's the cost for this kind of capability?
Well, looking at HDTV Supply, the kit price is currently $876. That's down from an MSRP of over $1,000.
And there's a discount code mentioned.
Yeah, 10% off. But honestly, the bigger indicator of value, I think, is the warranty.
Oh, what's the warranty?
It comes with a 7-year Kramer warranty. That's pretty substantial.
Yeah.
Because they're confident in the build quality and reliability.
7 years is definitely reassuring for infrastructure hardware. Okay, so let's wrap this up. The big takeaway seems to be that this KDS USB2 kit fundamentally changes USB from a short-range point-to-point thing.
Into a high-speed, potentially massive network system for control and data,
Hmm.
basically shattering the distance barrier.
Right. It makes USB devices function over standard network infrastructure.
Exactly. And that brings us to something to think about, for anyone designing these kinds of systems.
Go on.
This whole thing relies on standard networking, 1000 base T specifically. But it cleverly separates things. It uses layer 2 networking for the actual USB data transport.
The raw signal packets.
Right. But it uses layer 3 networking for the control traffic, that's switchable USB mapping and management stuff.
Okay. Data on layer 2, control on layer 3.
So the question for you to ponder is, how does separating the data path from the control path like that fundamentally change how you should think about designing large-scale remote collaboration systems, especially when you consider things like latency, reliability, and security for each path?
Interesting. Does separating them let you prioritize or manage them differently? That's definitely something to chew on.